right, so let's look at some of our problems here and how we would solve these examples now that we've gone over the actual empirical rule. So a couple things before I get started. There are typos in the notes packet on this example 1. So before we can even work the problem, the numbers that are in there, you can't even work the problem out. Doesn't make any sense. So we need to change the numbers. So I've already written them in here. We just need to change these numbers to be what I have written down. It's the only way we can work the problem. I promise you, everything I give you in my math lab and on the tests and the quizzes and all that stuff will be able to be worked out. This was just a typo that we didn't catch till we already sent it to the printers. So just go ahead and change those real quick. All right, for these problems, I'm always going to give you the mean, which I had to change there, and the standard deviation. So you're not going to have to find those. You're going to be given that information. You're going to be told that we're dealing with, it could come up in a couple different words and synonyms here, bell-shaped curve. Let's see, down here it's going to say normal distribution. It might say that symmetric. They all mean we're going to use that empirical rule to solve the problem. Now I have to draw the picture in order to solve the problem. So I've got this space down here. So I'm going to draw, it's not going to be beautiful, but I'm going to draw my picture here. In the middle, I'm going to start with the mean. Remember, I've changed the mean, so you need to change that in notes packet. I count by standard deviation. So to the right, I'm going to add 3,750 here. So, and I do it 3 times. So adding the mean plus the standard deviation gives me 128,750. And I've got to do this 3 times. I know we're going to have to squish it in because these are really big numbers. Adding the standard deviation again would give me 132,500. And one more time would give me 136,250. Now on the left-hand side, I'm going to subtract. So I'm going to start with the mean and I'm going to subtract the standard deviation. So start with 125,000 and I'm going to subtract the 3,750. So that's going to give me 121, oops, put it in the wrong spot. 121,250. Subtract the standard deviation again. 117,000, sorry, 500. And subtracting again is 113,750. This number line at the bottom is what's going to change each time. You start with the mean in the middle, you add the standard deviations, and then you subtract them. The percents I'm putting here never change. This is the empirical rule. This is what we went over on that last video. They never change. They are always the same. Doesn't matter what's going on the number line down below. So I've done all the work. This is all the work for the problem. Now I want to know between this line all the way over to that line. Because I want to know the percent of homes between 117,500 and 136,250. So I'm going to add up all these numbers, all these percents. 13.5, 34, 34, 13.5, and 2.35. Type all those in my calculator and it gives me 97.35. So that's the answer for A. A wanted to know the percent, so I've done A. Now B is going to take it a little step further. They're saying we don't want to know the percent, we want to know actually how many homes that is. And they have to tell me the total. There are 35 homes, so I'm going to take 35 and I'm going to multiply it by that percent. And remember, we change percents to decimals. We'll be doing it all semester. We're going to keep doing it right now. So I'm going to change that to a decimal. It asks me to round to the nearest whole number. So that would be 34 homes. All right, so example 2, no typos on that one. We're good to go as it is. So what I want you to do is pause the video and see if you can set up that the curve, that number line on the bottom where you start with the mean and add the standard deviations and subtract. If you want to try the problems, you can do that as well, but at least try setting it up. So go ahead and hit pause and give that example 2 a shot. All right, so let's see how you did. We're going to start with the mean in the middle, and so that is 5'8". So 5 feet 8 inches, and the standard deviation is 1.5 inches. So I'm just going to count up by 1.5. So the next one would be 5 feet 9.5 inches. These are all awkward numbers to write on these little bitty spaces. I just got that by saying 8 inches plus 1.5 inches is 9.5 inches. If you wanted to change it from feet and inches all the way to just inches, I'll do that in just a second, but I'm going to work it just as it is right now. All right, 5 feet 9.5 inches, adding another 1.5 inches is going to give me 5 feet 11 inches. This is where it might get a little bit tricky. Adding another 1.5 inches to that gives me 5 feet 12.5 inches, but 12 inches is a foot, so that's really 6 feet 0.5 inches. Oops. I said it right, but I wrote it wrong. So 6 feet 0.5 inches. Now, you might not like the feet in inches, and that's okay. You could have changed it all to be inches so you didn't have to deal with the feet. 5 feet is the same thing as 60 inches because there's 12 inches in a foot. So that means 5'8" is 58 inches or 68 inches. Man, these problems get me today. 5 feet 9.5 inches is 69.5 inches. So you could have used these things in the 60s if you didn't want to use the feet and inches. It doesn't matter. We're going to get the same answer either way. Whichever one works out for you is what's best. So either way is fine with me. All right, I'm going to do my subtracting. Subtracting is a little bit easier, to be honest with you. 5 feet 8 inches. Take that 8. 8 minus 1.5 inches would be 5 feet 6.5 inches. Keep subtracting the inches. 5 feet 5 inches. And one more, 5 feet 3.5 inches. Again, you could have things there like 63.5, 65, 66.5. That's up to you how you want to write these. And then our percents are going to be the same every single time. Those don't change. So we want to know the people that were shorter than 5 feet 5 inches. So there's 5 feet 5 inches. Shorter is going to be below that. So I'm going to add all those together. So 0.15 plus 2.35 is going to give me 2.5%. And it just said what? This one said probability. Probability can be written as a percent. So we're just going to leave it as 2.5%. Second one here, want to know the probability that the women chosen are at least 5'11". Well, here's 5'11", right here. At least means we're going to be going bigger. So we actually get the same answer here, just a coincidence. So 2.35 and 0.15 equals 2.5%.